Well, hello class. Good afternoon. I think you guys are going to be watching this in the afternoon, and if you're seeing this, then great. You may notice you're having a new sub. It's Mr. Villaflores, so thanks, Sean, for subbing for me. Throughout this week, he's going to help me out. I don't know if you're in my classroom or in his classroom, but hopefully maybe a different sub who's a better version of me can help you out with this stuff in case you're confused. I was actually going to start with something else, but since I'm teaching you through video form, I'm trying to find a little bit easier topics that you guys can follow along via video. What you're going to do is you want to take out your notes. It's section 4.6. It says graphs of other trig functions. Some of you may have lost it or forgotten it or don't know where it is. So what I've done is I've photocopied a few of them. If you need a copy, maybe Brittany or Aldrin can photocopy a copy for you. But essentially, one of the standards that you just did on your quiz was graphing sine and cosine. So we're going to do two at a time. So you should feel comfortable, by the standard graphing sine and cosine. Today I want to teach you how to graph tangent and cotangent. First of all, you may be wondering, how does the graph work? So here's a unit circle. So just looking at the four main points, this is 1, 0, 0, 1, etc. Now find the tangent of those points. Do you remember tangent means the exact same thing as sine over cosine? So remember the sine is representative of the y-coordinate and x is representative of the cosine, or the cosine is representative of the x-coordinate. So if I do sine over cosine, you notice that if I do sine over cosine on this one, it's the same thing as 0 over 1. 0 divided by 1 is 0. So I could say the tangent of 0 is 0. But look what's a little bit different with this problem. When I do sine over cosine, for this coordinate right here, I get 1 over 0. And this is where people get confused. What is 1 divided by 0? You can put it in your calculator in case you forget. But 1 divided by 0, if you put it in your calculator, you should get error, or undefined. Okay. You'll notice that these problems are exactly the same. This one's 0 divided by negative 1, I get 0. And here on the bottom, if I do negative 1 divided by 0, I also get error. So what does that mean in terms of graphing? Well, here, maybe I'll type it out. So in terms of radians, this is 0, right? This is, I'll just use p. This is pi over 2. This is just pi. And this is 3 pi over 2. So what that tells me when I graph, at 0 I should have 0. At pi I should have 0. At pi over 2 I have an undefined, basically I have no number, nothing exists at pi over 2, and the same thing with 3 pi over 2. So what I'm going to do is I'm going to give you a regular graph of tangent. So if you want to go down to your paper, remember the period for sine and cosine was 2 pi. Well, the period for tangent is pi, which means every pi, like every length of pi, it repeats the same wave. The domain, if you don't know to read this, that means I could plug in every number except for pi over 2, and then every multiple of pi. So pi, 3 pi over 2, 5 pi over 2, 7 pi over 2, all those don't exist, or all of those give me error. Range means I'm going to go all the way to the bottom and all the way to the top, or my y values stretch all the way from negative infinity to infinity. And vertical asymptotes, this is why I get my error. Every pi over 2 and a multiple of pi. So pi over 2, 3 pi over 2, 5 pi over 2, all those pi over 2s, I have a non-existent number, or I get an error. So here's how the graph looks like. So first of all, I'm not going to really follow these lines. Oh, okay, fine, I'll follow these lines. Let's say 1, 2, 3, 4, 5. Let's call this pi over 2. And let's call this 1, 2, 3, 4, 5. Let's call this pi. So remember, the period is pi. Okay. Remember at 0, going back to my unit circle, I'll look back. Remember at 0, its tangent is 0. So I know I'm going to get this. Okay. Remember at pi over 2, I get error. Wherever I get error, what I'm going to do is I'm going to draw a vertical line. I know some of you are going to say, oh no. So vertical line through pi over 2. And at pi, you see it's 0. So if you're confused, just follow me here. What you're going to do, how the graph looks like, is I'm going to start at this point. I'm going to draw a line basically going towards infinity, towards pi over 2. I can get this to work. There, I'll start from here. Like so. So from 0 to pi over 2, I'm going all the way up to infinity. And on the other side of pi over 2, I'm going to start from negative infinity and go all the way up to pi. That's how tangent works. Okay? Remember how at the end we did these little dotted lines? So how these graph looks like is actually like this. So basically they look like tiny little tails repeating forever and ever. Again, you don't really need to write these, but you just need to know that this repeats on and on and on forever. So every pi over 2, 3 pi over 2, negative pi over 2, I'm always going basically like these little waves. Okay? Some of you are confused. I know you hate graphs. We've done so many graphs in this class, but I have to teach you tangent. Cotangent is actually the inverse of tangent. Okay? So what I'll do is I'll do the same thing. I'll have pi over 2 here. I'll have pi over here. Okay. Remember, the inverse is basically a function flipped. So what I'm going to show you is that instead of wherever tangent is 0, instead I'm going to have a vertical line. And wherever I had a vertical line, I now will have 0. Okay. And because it's the inverse, what I'm going to do is sort of, I'm going to flip it. So remember where at 0 I get a vertical line. So see how I had a 0 here, so vertical line. I had a 0 here, so vertical line. And then I guess I drew this vertical line on accident, but see how a vertical line of pi over 2? This now just becomes 0. And all I'm going to do is essentially it's like the tangent line, but going in the opposite direction. So let me use a different color. It looks like this. And if I wanted to repeat it on and on and on, it looks like that. Looks like that. Okay. So that is how you graph tangent and cotangent. Okay. Things you need to be aware of. So let's go on to the next page. And again, if I'm going too fast, maybe someone can pause me so you guys can copy it down. I don't want to go too fast, but then since I'm not with you, I don't know if I'm going too fast or I'm losing you guys. So here are some things that we need to change. Okay. So just the same thing as sine and cosine. Remember, there's period, there's amplitude, things like that. Okay. So remember that if you have, how can I say this? If you change the period, it'll change where my asymptotes are located. Okay. If I have a negative sign, like if I have a negative out in front, that means I'm going to essentially flip my graph. You guys remember that from the beginning of the year. And then amplitude, remember for sine and cosine, like it made my waves stretch. So if I had like an amplitude of 4, I had to start at 4 and end at 4. Well, you know, for tangent and cotangent, like that doesn't make sense. So amplitude for tangent, if you have one that's greater than 1, like 4 tangent, it means your waves get really straight, like almost like, basically almost steeper. But if I have less than 1, it means it's flatter, which means it's a little bit slower to wind. And obviously you're estimating, just like all these graphs that we've been doing. So what you're going to do is sort of guesstimate if it's less than half or whatever, you're just going to make it flatter or steeper. So let's look at this first problem. It says tan x over 2. Okay. So obviously I'm graphing tangent. But you notice, like this problem, would you agree I could rewrite it as the tangent of half x? Okay. So I'll do the period thing again. I think some of you like degrees. So I'll do it in degrees, and then I'll also show you in radians. Remember the typical period in the past, in sine and cosine, it was 360, or 2 pi. But remember in tangent, if I go back to your last page, my new period is just pi. So my new period is going to be pi, or sorry, let's do degrees first, 180 over half, or 360. Or if you want to do it in radians, like depending on what the problem is, 2 pi over half, or sorry, pi over half, because this is tangent, pi over half, I'm going to get 2 pi, which makes sense because 360 and 2 pi mean the exact same thing. So what does that mean for you? Okay, that means, see how my previous graph on tangent, I went all the way to pi and made the graph? Well, instead, since my period's 2 pi, again, I'll just pick a random point, 2 pi, and then halfway, I know it's not to scale, and then drawing a line randomly, it's pi. And I'll draw the exact same graph as up top. So see how my period is pi here? I had the halfway point, and I went all the way up to infinity, and then back down to negative infinity up to pi. I'll do the same thing, but the only difference is that I'm saying pi over 2 and pi, I'll write pi and pi over 2. And the same thing, I'm going to have a I'm going to have a vertical line here. And I'll have it go from 0 all the way to infinity. And then from negative infinity all the way to 2 pi. And again, repeats on and on and on forever. Okay. And you'll notice, technically, I mean, I'm drawing it very ugly because I'm doing it on a mouse, but this should be like a standard tan line. So here we go, example 2, it says negative 3 tan 2x. So you'll notice a couple things. One, I have a negative, which means I'm going to flip it. I'm going to reverse direction. Okay. And you'll notice that I have this 2x now. So let's do the same thing. Remember the normal period is pi, or the normal period is 180. I'll divide by what number is right here. So the last one, it was half, and this one, it's 2. So my new period in radians is pi over 2, or in degrees, it's the same as 90. So the last example, we did radians. Let's do let's do degrees. So see how this is 90, or my period is pi over 2. So that means, and again, if I did this to scale, so I know I cheated. See how this is pi and 2 pi. If I did it to scale, you know, 2 pi should be out here, and I would make a really long tan line. But I'm just trying to fit it into this. So let's just say, just to be nice, let's just say here's pi over 2, right? So I'll make pi over 2 here. I'll make this pi. So I'll line this up to make it sort of nice and neat for you guys. So you could tell, you could see what the period does. Okay. So since my period is pi over 2, that means it's going really fast. That means the midway point is pi over 4, right? Half of pi over 2, or half of half is pi over 4. And normally what I would do is I'll have my vertical line here. What I was going to say is normally, remember I started at 0, 0, and I go up. Well, this time, since it's a negative out in front, and since it's a 3, I have to make this really steep and make this essentially go really, escalate like steeper or straighter. So here, normally I'd go like this, but since I'm reversing direction because of this negative sign, instead of going from, so this is with a positive sign, so with the negative sign I'm going to do this. And I'm supposed to make it as steep as I can, like so. And then since this goes to negative infinity, I'm going to go from positive infinity to pi over 2. So that's my attempt to make it super steep. And because these are tan lines, these are trig functions, they repeat over and over. So you notice that if this number out here is a real number, or a whole number, my lines get really like condensed. Whereas if that number is a fraction, you may have noticed that it's all spread out. Let me do one cotangent before I let you guys go. So this one's 2 cotangent x to the third. Normally my period, let's do this in degree. I know I said I was going to do degrees. So normally it's 180. Normally it's 180. I'm going to divide by, you see how this is 1/3 times x. I'll divide by 1/3, which makes my new period, flipping this 180 times 3, which is 540. Okay, and I'm going to run out of time here. So 540, let's just put 540 here. Let's just put the halfway point is 270. So remember, cotangent is exactly the same, but wherever I used to have the vertical line, I'll put a 0. Wherever I had a 0, I'm now going to have a vertical line. And remember, I'll go back to the first page. Remember, it starts like backwards. So what I'm going to do is go from here, and see how this number is 2, so it's supposed to be a little bit steeper. So I'm going to make it a little bit straighter, like so. I mean, it's not the nicest graph, but that's how it looks like, and then it repeats forever and ever. That's how you graph tangent and cotangent. I'm running out of time. See y'all later.